Hey guys, thought I'd make a video. I hope it'll be quick or multiple parts, but I'm prone to rambling on, so we'll see what we can do. This is going to be about bolts, mostly focusing on Land Rover type crown wheel bolts and the diff bolts. Reason being is I see a few things lately that are interesting and some things that I don't agree with. And like everyone, I've got an opinion and you're bloody going to hear it. But these are a bunch of bolts here, mostly Land Rover genuine bolts. That one's not, that one's not. So with the crown wheel, you may have pulled them apart yourself and you may have seen this particular bolt holding them together. The crown wheel bolted to the diff hemisphere. Now, just quick note, that's an Ashcroft heavy duty 3.75, and that's a maxi drive Rover type hemisphere. There's the locking spline on the side. I can talk about this another time if you want, but this is for my own vehicle, nice strong ring gear in the ratio that suits my needs, and lockable centre diff. Again, a much greater upgrade to Rover, but you may have seen this type of bolt. And some people will say, hey, they're junk, throw them in the bin, get rid of them, don't even look at them, they're terrible. And the other two bolts you may have seen, genuine Land Rover bolts mind you, are these flange bolts. This bolt here had a run for a few years, starting in late 90s, so like mid to late 90s, so let's say 96, around then, 97, which then got swapped out at some point by these. I can't tell you when. I think I've seen these on diffs maybe 2010 even, which I was surprised. I thought they stopped earlier than that. But if you buy brand new bolts from Land Rover with the same part number, these both share the same part number, this is what you're going to get, this style. I have two brand new ones here. That's the bag that they came in literally yesterday. Genuine Land Rover bolts. So the old crap apparently bolt was around. I know I'm not in a series aficionado, so I don't know what the original series ones had. If you know that stuff, hey, throw it in and let us know if it was it a British Standard thread like a Whitworth or a BSF thread. These are all 3/8 UNF. The Rover diff from at least the 60s and maybe even the 50s, but at least the 60s, 70s, 80s, 90s, right through to the end of the Defender in 2016, 3/8 UNF. So that's the fine UN thread, the UN Unified National Fine. The Salisbury is different. Ironically, an American-based, so it's Salisbury made by Spicer and Dana, or the company name changed a few times in the UK. It's an American, based on American differential, but ironically, the POMs made it metric. Okay, so they're M12. I'm pretty sure the crown wheel bolts are M12 thread. So we're just looking at the Rover stuff for now. So they're the bolts you're going to get, genuine Land Rover bolts if you pull apart a genuine Land Rover diff that hasn't been played with. So most probably those. There would be countless more of that type than either of those type, because they're around for so much longer on so many more vehicles. The flange bolt first appeared on a P38 Range Rover and then was used in some bolts. I've seen these on D2s and I'm assuming definitely some Defenders as well. So that, these are all automotive bolts, like I said, except for these two. There's 12.9 on that one. 8.8 on that one. So there's a few numbers and markings on them. Where's one that doesn't have that on it? So no, that's not a good indicator. This one here, and again, if I had a Land Rover bolt, see there's radial markings that come out. Forget the letters. The letters are probably just manufacturer's markings, but those lines or dashes that radiate out from the centre, that is a representation of the strength of that bolt. Just like on the metric bolts, the numbers represent the strength. So the metric system is referred to class or classification. The imperial, the UN, UNF, UNC, is they call it grade. So this is a grade 8. Even though there's 6 dashes, it's called a grade 8 bolt, and that those dashes represent that it's a grade 8, and then grade 8 represents the strength. This here is a class 8.8, and that represents the strength, just like you'll have some, say this one here, 12.9, that's a brake rotor to hub bolt. This one here is a caliper, brake caliper to swivel housing bolt, that's 10.9. This big one here is actually the carrier bearings. So these are the carrier, this is a carrier, these are the carrier bearings, the caps that go over these and secure this into the cast iron housing. They are these coarse thread, and I'll get to why they're coarse, but they're 8.8, class 8.8. The crown wheel bolts that we have that are stamped are both stamped 12.9. This bolt is not stamped. I am not 100% if those reliefs in it, those radiating reliefs, represent the grade, as in grade 8. And the reason I say that is because there's a reason behind this head design, which I'll also get to. But the irony of it is these are imperial thread, 3/8 UNF, and they have a metric rating system. My guess for that is that under the SAE, one of the governing bodies that overrule and foresee and set the standards for the UN thread system, which is a Unified National Thread Standard, and there's UNF, there's UNC, there's UNS for special, there's UNR for radius. They have grade 2, grade 5 and grade 8. And then they have socket head cap screws. They don't have anything above grade 8 that they officially recognise at this stage. Metric have 8.8. There's also a 9.8. It's very rare, but it exists. There's 10.9 and then there's 12.9. So my guess is that Land Rover spec'd what class or strength of bolt they wanted and a 3/8. Normally they would mark this with an imperial marking to show that that's what it is, but there is no rating for this strength. If you look at 12.9, it's 176,000 psi tensile strength, or 1220 MPa. If we go to grade 8, which is, like I said, their recognised highest, it's only 150,000. So I think that's why this is weird, because you normally never find imperial bolts with metric markings on them, and that's definitely a metric system, and it's definitely an imperial bolt. So there is such a thing as grade 9, but it's not fully recognised yet. There's some very good quality bolts made in grade 9. There's probably some junk as well, but like Holochrome make grade 9. There's a few companies in the States that make grade 9. I believe earth moving equipment, Caterpillar, and possibly bigger John Deere and stuff like that, they make some very high quality bolts, and I believe some of those are quite high tensile strength. The metric system's good or interesting in the sense that the numbers actually relate directly to the strength. So when you've got 8.8, you've got 8 times 100, 800 is the ultimate tensile strength in MPa. So tensile strength is if you were to get this bolt and stretch it lengthways until it's snapped. So there has to be a minimum requirement to, like the 800 MPa minimum requirement to class that bolt as an 8.8. The 0.8 is 0.8 of that 800 is the yield strength. Now yield is if you stretch this bolt, if you stretch it a little bit, it's steel. The steel will return back to its original length if you don't go to yield or beyond. So you can stretch it, it'll come back once you release the pressure. So yield is the point that it will not return back to its original length. So right at that point that it will no longer return. So 0.8 of the 800 is the yield strength. So you've got tensile strength and you've got yield strength. They don't mean really much to me and you, other than the fact that if that's what's in the part from factory, that's what the engineers have designated as a requirement for the job. They look at the problem, in this case it's attaching the ring gear to the flange of the carrier, or the carrier bearing cap bolts. retaining them down. They look at all the forces involved under normal circumstances with normal size tyres, factory tune, factory gear ratios, factory, weights, and they'll say, okay, there's X amount of force at the worst, and we need this to retain that to do the job, to clamp it. This is all clamping. So the bolts are classed that so they can be identified and meet standards. The engineers can pick from a range of approved specifications of bolts for what needs their requirements. So you and me, we're not choosing that. We're just saying that's what it is. Different bolts, different lengths, different threads, and strengths depending on the job at hand. Most of the bolts if things are well designed in, mechanical drive line, will be loaded mostly in tension, maybe even in theory only in tension. I believe you will see potentially some shear in these, but mostly it's clamping force that creates friction between the back of the ring gear here, or crown wheel, and the face of this. It's that clamping force that creates a lot of tightness, the two surfaces friction, and that's what stops it actually spinning and therefore shearing the bolt. So you get enough clamping force, you get X amount of friction, and it's going to overcome any resistance to actually spinning and shearing. So bolts are all rated in tensile, so tension, and this way. They're not rated in shear. That can be figured out. There's formulas for that. I'm not an engineer, so we're just looking at what comes with them and what's going on, and a bit of like why this was. The other thing about automotive bolts, if you go to a nut and bolt shop, fasten shop, I don't know what it's like in other parts of the world. I can only talk for Australia. The bolts you're getting are considered industrial bolts. Okay, they're set lengths and set thread lengths depending on the length of the bolt. Land Rover, when they're building their vehicles, specify their bolts so they can choose how much smooth shank or grip length they come with. Some will have none. That's a stub axle 10.9. That's stub axle to swivel housing bolt. Okay, that's got none. Caliper bolts got that much where it goes to the ear of the brake caliper. The rotor bolt's got that much, So I have a feeling the things that possibly they have a feeling they're going to see a bit more shear, possibly have that. It's really good practice to have that sort of thing in a non-threaded portion like there. Will that pass through? No, it won't. No. So, that one either not. So you've got a non-threaded section through there. They deem whether it's necessary or not. Clearly not. So I like the idea of it. It's very important where this ends in relation to not only bottoming out, like if you had too much smooth section and it came through and you were tightening this and it was, it wasn't really obvious, like it wasn't like that super obviously long. It was only just a tiny bit long, but it was bottoming out, which created friction, which would give you a higher reading on your torque wrench, but you wouldn't be getting the clamping force. That's a problem. The other problem is where the thread meets the smooth shank, right there where my thumbnail is, if that makes sense. That's the weakest part of that bolt. What you don't want is that point, and this is taking away bottoming out. Let's say we're not bottoming the bolt out and jamming it on this part here when we're trying to do it up. Where that thread meets that smooth shank, that's the weakest part of that type of bolt. You don't want that in the line of the crown wheel and the hemisphere, because right at that line there where my fingernail is the highest point of stress against the bolt. So you want it about maybe one or two thread, when I say threads, like full rotation threads back. And that's good practice. So, you want some of that in there. But like I say, Land Rover don't deem that necessary in this application, rightly or wrongly. That's just what they do. This old school has a little bit. Again, that could be more to do with the design of this bolt, and we'll talk about that in a sec. So we've got some metric bolts, as Land Rovers have some metric bolts, especially from the 70s onwards, or like the early 80s onwards, and they have some imperial bolts. My Defender's a 98 model. It's mostly metric. the rear A-frame still has, or still had, imperial bolts at the UNF, half-inch UNF at the A-frame, bolting it to the A-frame arms, and the A-frame arms and bush to the chassis are 3/4 grade 5. I think these ones here are UNF grade 8 at the A-frame. My vehicle is in the middle of being completely modified. I mean, really modified. I've made all new suspension components, all new links and everything. I'm using the A-frame, and I'm using what Land Rover used. And I've, bought brand new brands that I know, like for us, Hobson or Brighton Best, good quality bolts with the correct length of shank. I just work with what I can get within designing stuff as well. So the vast majority of the bolt through the 2 parts or 3 parts or whatever and brackets is all this, and that the thread is only where the nut is and the washer. So we don't always have that luxury, especially if you're buying bolts from the shop. Like a bolt like this would, if you bought it from the hardware or the nut and bolt fastener shop, that will be fully at that length. That would be fully threaded. You wouldn't get any smooth there. So there is often a good reason to buy automotive, your Land Rover bolts for your Land Rover. The other thing too, from personal experience, aftermarket brand Land Rover bolts, I would personally steer clear of them. I've bought some brand new, opened them, put them into parts and purposely broken them to see, because I was suspect on the quality of them, and they were marked 12.9 and they would have been lucky to be grade 8, or I suspect they would have been closer to class 8.8. They were horrific. And they were part number for part number. They were not genuine Land Rover bolts. And that was just enough for me to say, I am never trusting. And these were structural bolts. These were swivel ball to axle housing bolts. And there's no way you want to put something inferior there. So a lot of the Land Rover stuff, we can have a laugh and that, but a lot of these bolts are good quality. If they're in good condition, they can be used again. They're designed to be used again, unless it specifies in the workshop manual, 1 use only, or throw away, or only use new bolts. Some head bolts on engines are torque to yield, and you use them once, you install them correctly, and then if you ever have to take the head off and the bolts out again, they go in the bin. Of all the workshop manuals and everything I've read, and I'm talking genuine Land Rover workshop manuals, not reprints by other companies, so far, I have not seen anything about crown wheel bolts being 1 use only. You must use new bolts, throw away the old bolts. And there's a bit in bolt design. So we talked about ultimate tensile strength. That's the strength that it takes to stretch the bolt until it snaps. Then we have yield strength, which is the amount of strength it takes to stretch the bolt and to the point where it will not return back to its original length. And then we have something called proof load. And proof load is the amount of strength or force you can put into a bolt, and it will always return back to its original length. So, you want to have your torque value that, and this is deemed by the engineers and the people that, when they design all this stuff and write the workshop manuals, the clamping force wants to be near the proof load. It's certainly not above it. So, yield on these bolts is the 0.8, it's 80%. On these other ones, the 12.9s, it's 90%. That's yield. Proof will be somewhere around 90% of yield. So, it's less than yield. So you've got tensile, yield, and then proof. They might say, okay, the clamping force we require with that bolt might be 80% of the proof load. So we're not figuring that out. It's just things that are taken into consideration. And when they say that, well, if you're only going to 75, 80% of the proof load, that bolt should always return back to its original length. If if the threads aren't damaged, everything's clean, it's been installed correctly, everything's right, and there's been no overload to failure, then the bolt should return to its original length and be fine. And like I said, unless something specifies 1 use only, these are all multiple use bolts. Now, the easiest way to know, like obviously if the bolt's broken or twisted or something, you can see a twist or stretch marks. The threads will be the biggest indicator. If the threads are not uniformly spaced, and you can clearly see some are wider than the others, you can do two things. You can throw the bolt in the bin, or you can give it the flotation test, where you throw it in a bucket of water. If it floats, you can still use it. If it sinks, you throw it in the bin. So for a bolt, you can check it visually. You can get a good quality brand new nut of the correct thread and run it on and off. And if it, again, making sure there's no little one-off dags in the threads, making sure they're clean. If that nut runs on and right up and right back with the same sort of resistance, finger, no problem. If it gets a third the way on or fully on and then stops or gets really tight, again, throw it away. Throw it in the bucket of water, throw it away. So there's a few, and you can even use a thread pitch gauge, which is little things that look like combs, and there's multiple, you get like a little Swiss Army knife of them, and because there's all different thread pitches, and the pitch is the distance of the thread to the very next thread. So there is a lot. So metric use distance. So they'll say M, for example, this is M12, so it's probably by 1.5. And if we go somewhere here, metric course, it's 1.75. So there's one complete thread, like one thread, and then the next one will be 1.75 millimeters away for that M12 coarse metric bolt. For, the other ones that are M10 fine, they're only 1.25 millimeters apart. The Imperial system uses numbers of threads per inch. The 3/8 bolts are 24 threads, so they're designated 3/8-24. So 3/8 is the diameter, the nominal diameter, and the thread is 24 threads per every inch. Might be 16 for another one. It could be more or less. So there's these thread pitch gauges, and they're these little things that look like tiny little combs, precision made, and you hold that comb with the teeth in the thread, obviously the correct pitch gauge for your particular bolt, and if they don't all sit in there evenly, you've probably got a problem with your bolt. So always take a good look at your threads on your bolts. You should be cleaning them anyway when you're reusing them, whether you're lubricating them or Loctiting them, they definitely need to be cleaned. The holes, again, make sure they're clean. Little bottle brush, wide brush sort of thing in there, toothbrush, whatever. Don't run thread cutting taps in these threads to clean them. Last case, worst case, if you had to, I just don't recommend it. You can get things called thread chasers. They're specifically designed to clean up threads. They're like a thread tap. They're just the size a little bit tiny bit different, and they're not sharp cutting edges. So you can spray a heap of brake cleaner in the holes, whatever you choose to clean the threads up with, to eat whatever's in there, your Loctite or whatever, and then run your thread chaser in it and make sure they're really clean. If you're reinstalling something, something brand new like this, I'll give it a really good clean in parts cleaner and all this stuff, make sure it's really clean. But the point is the bolts are designed through engineering to clamp a certain load, to not fail under installation, and to meet those requirements. Obviously, where we come into a problem with our four-wheel drive, sometimes if we've upgraded the power, changed the gearing, certainly bigger tyres, tackling harder obstacles and stuff, we're putting bigger shock loads, and we're asking for the same thing to do more, and possibly that it wasn't designed for. So, we can upgrade this part, we can upgrade this part. Can we upgrade the bolt, or is there a need to, I guess, is the question. So, the fact that this bolt gets a bad rap is interesting, given, it doesn't look like much, but there's an interesting thing with this head. The way it's formed, it's actually called a place bolt. And place bolts go back as far as steam, the steam era. And the reason why this head is shaped like this and recessed in this way, and there's also a radial sort of around the shank, where the shank meets the back of the head or the bottom of the head, there'll be a radiused groove around the diameter there. That's all part of the system, which is this head is designed to be a shock absorber for high loads, like when you get shock loads. So not just your normal everyday loads, but your shock loads. So the bolt is of X strength, whichever that may be, and the head, as opposed to this style head, a standard head, or even a flanged head, is designed to act as a shock absorber. These have been used throughout the automotive industry on gears, and not just in Land Rovers, in many, Ford and all that, and also commonly found on flywheels to crankshafts. And flywheels to crankshafts see high loads and they see high shock loads. And this type of bolt was used for a very long time and possibly still is today. I rate this bolt as being a good bolt. I certainly don't think it's junk. I think the design is sound, and just because it's old, I don't think it's to be dismissed. I certainly think it's got more going for it than just a standard head bolt, even of the same quality and grade or class. So that's a little interesting about these bolts, and Land Rover used them for a bloody long time. Why they went to a flanged bolt, maybe the supplier, maybe there was some data on these, for a reason. I think the head of that bolt is less forgiving by design alone. Let's assume these were both the same strength and quality. I'd say that head is less forgiving. So good or bad, I still think that's a good bolt. I think it's a good design, and I'd say the quality is pretty good. I think there's a lot going on, and there's some well-known race car engineers that would buy this type of bolt to install on crown wheel bolts. And I'm talking actual engineer trained guys doing head of team car racing, very well known. So that's sort of saying that style of bolt. Now, it's been said that they're possibly, not even grade 8.8 or something. There's no such thing as grade 8.8, but class 8.8. So I suspect they are, given the torque values of these in the Land Rover workshop manuals, and not only the series workshop manuals, but the Defender workshop manuals up to 98. I'm talking the genuine Land Rover workshop manuals. All the torque ratings for the crown wheel bolts are, in the series, they're 45 to 55 foot-pound. The Defenders, they have them a little bit lower, 40 to 45, and then they change. Obviously, they're deciding that everyone's metric in the late 90s. 58 newton meters, which is 42 and a half, so that's right in the middle. So that 42 and a half, 40 to 45 foot-pound is what they're saying that these bolts, and potentially these bolts. And the reason I say potentially is I can't say for sure, because I don't have a later than 98 workshop manual that shows torque settings for the crown wheel bolts on a Rover or P38 diff. If someone does, let me know in the comments what the value is. Now, given some research into torque settings for 3/8 UNF bolts, grade 8 and even higher, being at around 45 foot-pounds puts this at least grade 8, not 8.8, because 8.8 is only equivalent to grade 5. And if we go back to the little tables in the little engineering handbook, 8.8's there, 120,000 PSI. If we go to grade 5, 120,000 PSI. So grade 8 is 150. I suspect that these are at least grade 8, if not getting closer to 10.9, or sorry, that is 10.9 is grade 8, sorry, 12.9, given the torque values for installing these. And all the torque values in the Land Rover workshop manual are with Loctite, so that's a lubricated torque value, because you will have, if you look at fairly good torque charts that are just generalizations for torque for bolt sizes and threads, they might have at least 2 or 3, or they'll have a little asterisk next to the numbers, and they'll have a little chart down the bottom that'll say, so they'll say plain black threads, that's a plain black thread. There's no coating on that other than the black phosphorated coating. They'll have one for zinc. Now, I think most of the time that the black, whatever the chart will say, will be the rating or torque value for this plain black bolt, dry, no lubrication, clean, dry threads. This one being zinc, I think it's 70% of that roughly. This is a light, electroplated coating, because it's a little bit less friction. and then they'll have one for lubricated and like this. So the fact that Land Rover give their rating with Loctite, Loctite acts as a lubricant. It's going to be based off a lubricated thread installation procedure, and yeah, I think these bolts are going to be pretty bloody good, to be honest. What I've done here, I've got some 15mm thick 1020 steel that I had lying around, some bright bar or cold rolled steel or whatever you want to call it. It's better than mild steel. It's not a chromoly or anything, but it's a little bit better than mild steel. I've drilled and tapped it for all these bolts. These are all 3/8 UNF except for these two, which are metric 10, M10, and they're coarse. Now the reason being that is to give us an idea. I'm going to break all of these bolts with a torque wrench, and it's pretty unscientific, but it's just going to give me a bit of an idea, and then I'll post up the results in another video. I want to see what 8.8 is, and that should be the same as these. So these are grade 5, these are grade 8. We're assuming at least grade 8 unknown. 12.9 as the genuine Land Rover bolts that came in the blister packs, and these are socket head cap screws, which are 12.9 as well. I want to see how these, and unfortunately you can't buy an 8.8 in a 3/8 UNF. So what I looked at was the root diameter, or the smallest diameter of the bolt, and they're all fully threaded, and they're all 25mm long, except for the special Land Rover ones, which are what they are. But the root diameter of the metric 10 coarse is within 0.02 or 0.2. It's really close of a mil, really close to the same root diameter as that. Now, yes, the thread pitch will create different stresses, and there are variables. This is, like I say, I don't consider this scientific, but it's not completely unscientific. It'll be interesting to see what torque values I can do these up to, and then if they actually just snap. It's not a tensile strength because we're twisting it. I will have some 10mm flat bar in here with holes in it that don't rub on any of these. That'll be the same as this flange. So it's sort of like a flange, and then the same thickness as the crown wheel, and we're just going to see. I'm going to see what they break at. I'm just interested. That'll be especially these, but these give me some sort of base sort of number to work off, and it'll be interesting to see what these and these break at. I know I've broken socket head cap screws before, incredibly hard to break them. It'll be interesting to see if these come close to those as well. So it's a little bit of information, probably just rambling on there. Hopefully it's showing something. If you've got any questions or comments, please throw them in the comments. If you're an engineer and you can add or correct where I've gone wrong, great. Be interested to hear. Yeah, there's a lot to bolts and threads and joints. It's a world in itself, an engineering world in itself, and it's in, there's a lot going on there that people driving around in cars and stuff, and people that modify cars. We really should be setting our standards as enthusiasts as high as we can. Because it's not only our lives and our family lives that are involved when we're driving on public roads, it's other people's lives as well, and that's something that I'm quite adamant about, doing something the best that I can, and whether it's the design of something and the fabrication of something, I try and do the best that I can possibly do based on sound engineering practices, rather than just what other people are doing. The one thing I'll say about the socket head cap screws, and the reason why I've included those, is it's become more popular lately, and I say that because I'm only seeing them in videos in the last couple of years and on YouTube and photos on the internet. People having diffs built by, diff builders. I'm specifically talking Land Rover here, and they're using socket head cap screws on the crown wheel. Now, the good thing about socket head cap screws is if you're buying a known brand, you're getting a good quality bolt or socket head cap screw. It's a known quality. The threads are made to a high standard. It's class 12.9, but it's not just about the numbers, it's about the quality. And if you're buying these known brands and these bigger Land Rover diff companies, and I'm not knocking them at all, I deal with them, and buy their products and give them support, and they've been great to me over the years. This is a personal observation. So I think, one, it's a good way of easily getting a quality bolt, because it's unfortunately harder to get good quality bolts these days because everything's gone to China. the quality control isn't there in general. There's a lot of cheap Chinese stuff. I'm not saying all stuff's in China's bad. Some of these very well-known companies get stuff made in China, good quality control. They've got people in place. They're spending the money for the standards and just checking the materials are right and the procedures and everything are right. But you go to your local nut and bolt shop and who knows what they're getting, because their supplier gets a big load of something in cheap and it's come out of some random factory, and it's so easy just to put something on a box and say it is what it is, or stamp it in the head. So I suspect they're going to socket head cap screws because there has been some failures of these later Land Rover bolts. I don't particularly put it down to the class of bolt, like the strength rating. I put it more down to the length and the fit and finish of the bolt. When you compare these two bolts, and sorry if I'm repeating myself, the earlier version is much nicer than the later version. It's longer, it's the correct length in my opinion. Just the forgings, everything about it is a lot nicer than this bolt. You can't buy this particular bolt. There's no different part number for it. I haven't been able to find a supplier for it. You go to Land Rover, you ask for the part number, and this is what you get. These are the two versions, brand new out of packet, which are identical to this one. So they've probably gone to these because easy to get a quality supply. There's been some failures with these. The problem with the socket head cap screw is the reduced head area. These are a machine screw. They're often used in, machining and machine tooling because they can counterbore these into a pocket very easily. That reduced area is a bit of a problem. Now, if you're ever using socket head cap screws and you're using them for their strength for a reason, you must use them with a ground and hardened washer. If you use them with anything other than a ground and hardened washer, and this is the same for all bolts, mind you, but it's especially important for these with their reduced head area, is the clamping force that you're creating by torquing it to a set value is going to crush and deform the washer to a degree. The first time that part sees a shock load, that shock load will crush and deform the washer. And the problem with that is now you have reduced your clamping load. If you don't have the correct clamping load, in other words, it's the same as not doing the bolt up tight enough. It is as bad as over tightening it to deformation, whether you've deformed the bolt or the threads in the receiving end. There has been tests done, and I'm saying proper tests by the associated people, SAE, so forth. An example is taking a bolt, a high quality, high tensile bolt, clamping it to 40, so the torque that they did it up to was 40% of its tensile strength. They loaded that bolt with a set weight and ran it through a cycle like a fatigue cycle, so cycled it. They got 6,000 cycles out of that bolt torqued to 40% of its its tensile strength. They then got the same type of bolt, same quality, everything identical. They fastened it or torqued it to 75% of its tensile strength, I think it was, which is more what you would do. They cycled the bolt with the same machine, with the same weight, and they got 6 million cycles before it fatigued. That's not a mistake. 6,000 under tightened failure, 6 million when it was tightened properly. So that's a vast difference. So socket head cap screws, it's extremely important to have a ground and hardened washer. And any of these tensile bolts, I mean, these bolts they don't have a washer with them. The flanged head idea is you don't use a washer. These bolts absolutely have a washer, and you'll see these washers are a nice thick washer. I would bet my left nut that is a ground and hardened washer because they have not deformed, so that's a good sign. And they should be ground and hardened washers on any of these, but especially these. I believe that some of the diff companies installing these are using what is called a Nord lock washer. They look to have a reasonable surface area. My understanding is those washers are hardened. They're conical, like a bevel washer, like a cone to a degree. They act like a spring or a spring washer per se. They're the only washers you would use with spring washers or split washers are junk. There's a reason why they are. They're just bullshit as far as I'm concerned. They're a waste of time. All they do is deform the surface of your material, your car body, your chassis, whatever, or underside of the head, and they don't offer any value for undoing. For the split washer design or spring washer is meant to stop something undoing. Anything of structural value or tensile strength, they're just junk. So if you're using these, again, it wouldn't be my first choice because I don't think the head's forgiving, although the Nordlock washer is meant to be doing that. A personal preference, I wouldn't personally use these in a crown wheel. If you are using them, make sure you're using a ground hardened washer at the very least, and look into the Nordlock is the brand, NORD, Nordlock, high quality washer of the correct diameter to suit the 3/8 UNF, and make sure they're ground and hardened. So that's for something, anything structural, mechanical in a Land Rover. So that's why I've included these, because these are become popular in crown wheels. Now, if you buy a 1-inch bolt, which is 25mm, or a 25mm bolt for that in UNF, 3/8 UNF, there is no smooth section. It's all thread. Again, that might be fine. If you buy one this long, it comes with a smooth section. Now, I'm pretty sure, and you'd have to absolutely triple check it, but that with a washer, well, even that won't come through. So that's not a bad choice. What do you do with the rest of the thread? You cut it off and you dress it. I would personally cut them off with a hacksaw. It's boring as batshit. It's slow. It's annoying. But if you cut these off with a grinder, you have a chance of introducing heat into them, which may affect the heat treatment of the steel that they've used, and that's something you don't want. So if you're going to choose a bolt by the grip length, and you have to buy a longer bolt, and I've done that in parts of my build, absolutely, I will cut them off to the right length, and then dress the ends with some sandpaper, no heat, just sort of get all the ends nice and make sure the entry is beveled, like the end of that's beveled, so we're not damaging anything on the way in, and that way you might get the grip length, the smooth grip length you want. It's very important. So with these sorts of bolts where they have any smooth shank, the weakest part of the bolt is where that thread, the final thread, meets the smooth section. So it's important that, and I'm not even talking about bottoming out the thread into here and having this smooth section hit here and not achieving our clamping force and our torque. Regardless of that, and that's very critical, mind you, regardless of that, the weakest spot where my thumbnail edge is there, this is the highest amount of stress, is at this point here, where the back of the crown wheel meets the face of the carrier. We don't want that line of stress, of highest stress, at the weakest part of the bolt. So you would always have, say, 2 full threads inside the hemisphere flange, and then the smooth body. And that's any bolt. That's not just socket head cap screws. That's any bolt. That's just basic good bolt installation, so to speak. So there's a bit to digest there. Sorry I've waffled on for so long. Hopefully it's not been too boring. If you've switched off halfway through, don't blame you. Any comments, fine, throw them in there. I'll answer anything I can, or I'll be happy to hear different opinions, especially from engineers. But yeah, geez, I'll snap all these. We'll see what we can do, and I'll offer a few things that I think about installing the crown wheel to the hemisphere, and maybe even talk about carrier cap bolts as well into the main third member, cast center section, whatever you want to call it. Cheers.